Welcome to Brain Vision.
Well, we have the mass of the ball. The mass of the ball is equal to 0.4 kilogram. My mass is 70.0 kilogram. Let's write down mm for my mass. Well, that is equal to 70.0 kilogram. And the speed of the ball that is thrown with is VB1, and that is equal to 10.0 meter per second. Well, we know that the total momentum of a system is the vector sum of the momenta of the individual particles that make up the system. So P is equal to PA plus PB plus so on. Let's call this equation number 1. And momentum P is given by mass times velocity. Well, let's call this equation number 2. Well, we also know that for an isolated system, the momentum of the system is conserved. So momentum P is equal to constant, right? Now let's do calculations. Well, since there is negligible friction between my feet and the ice, then the system is considered as an isolated system. So applying conservation of momentum, the momentum of the system before me catching the ball or the ball bounce equals the momentum after. So P1 is equal to P2. Initial momentum is equal to final momentum P2. Let's call this equation number 3. Well, we take the direction of the ball that is thrown in the positive direction. Well, first we plug our values for VB1 and MB into equation number 2. So we get PB1 is equal to 0.40 times 10.0, that is equal to 4.00 kilogram meter per second. Since I was initially at rest, my momentum is equal to 0, and the total momentum of the system before any action is P1 is equal to 4.00 plus 0, that is equal to 4.00 kilogram meter per second. All right. Now applying equation 3, the momentum of the system after any action is P2 is equal to 4.00 kilogram meter per second. All right. Well, now let's do part A. Well, if I catch the ball and move with it, the system can be considered as one particle. So the total mass of the system is m is equal to my mass plus mass of the ball, and that is equal to 70.4 kilogram. Now substituting for P2 and capital M into equation number 2, we have 4.00 is equal to 70.4 times V2. So V2 is equal to 0.057 meter per second. All right. And now we do part B. Now let's do part B. Well, if the ball bounces in the opposite direction with speed 8.00 meter per second, so with speed VB2, and that is 8.00 meter per second, then the velocity of the ball after it bounces is VB2 is equal to minus 8.00 meter per second. Now substituting VB2 and MB into equation number 2, we get momentum B2 is equal to 0.40 into minus 8.0, that is equal to minus 3.20 kilogram meter per second, right? And from equation number 1, we know that from equation number 1, P2 is equal to P M2 my 2 plus B2, right? And plugging our values for PB2 and P2, we get, now let's plug in values. 4.00 is equal to P M2, right, minus 3.20. So P my 2 is equal to, so momentum of mine equals 7.20 kilogram meter per second, right? And now we plug our value for PM2 and my mass into equation number 2. Then we have here 7.20 is equal to 70.0 times VM2, and solving for VM2 is equal to 7.20 divided by 70.0, that is equal to 0.103 meter per second.